Now we are being asked to find a formula for the nth term. So basically we need to figure out what's happening here in this sequence. I notice that in the numerator it looks like I'm dividing by 3 and then whoops, I can't tell if I'm dividing by 3 at all. We've got a little bit of trouble here. Down in the denominator, 5, 5, 5, 15. That won't reduce to 5. Perhaps I should try writing each of these over 15. If I put this first one over 15, that would be 6 over 15. The one before it, multiply by 3 down below, 3 up above, we have 18. Multiply by 3 down below to get 15. Multiply by 3 up above to get 54. Now I can see divide by 3, divide by 3, divide by 3. We are dividing by 3 up in the numerator. And then in the denominator, well, it's staying 15. So dividing by 3 basically tells us we are multiplying by 1/3 to go from term to term to term. Now, if we begin with a sub n equals a sub 1r to the n minus first power as our base formula, we can now say that our nth term is going to be 18/5, that was our a1, times 1/3, which is the ratio, to the n minus first power. And if you substitute 1 in, your first numerator is 1 minus 1, which is 0. Anything to the 0th power is 1, times this 18/5 gives us our first term, which is 18/5. And then when we substitute 2 in for n, we'll have an exponent of 1. 1/3 to the first power is 1/3, times this 18/5, which gives you the 6/5. So it appears that this formula indeed will work. Now, we are given the first term and the second term of a geometric sequence, and we're being asked to find the fifth term. Now, I personally would just say 16, comma, negative 12, comma, blankety, blankety, blank. Now I would just need to figure out what am I multiplying by to go from 16 to negative 12. 16 times some ratio r is going to equal negative 12. And if we divide each side here by 16, we will get negative 12/16, which means that r is equal to negative 3/4. Now we have two choices. Do we want to just manually multiply by negative 3/4 and say, okay, this is going to be positive 9, negative 27/4, and 81 over 16 as our fifth term? Or are we going to use the formula a sub n equals a sub 1r to the n minus first power and say that the fifth term is what you get when you start with 16 and multiply by negative 3/4 to the 5 minus first power? That will end up getting you to 81 over 16 also. One way using a formula, the other way figuring out what r is and then just filling in the blanks, multiplying by negative 3/4 as you go. In this next problem, we are asked to find a1 and r for the geometric sequence from this given information. We have the third term and the sixth term. So basically we are missing the first two terms before 45. There's a fourth and a fifth term missing before the negative 243 over 25. Now, I'm going to kind of break out of the formula mold a little bit here and use some reasoning here. If I start with 45 and multiply by r, and then r again, and then r a third time, we have the negative 243. In other words, 45 r to the third power, 45 multiplied by r 3 times, equals negative 243 over 25. Now, if we divide through each side by 45, we have r to the third equals negative 243 over 45 times 25. Now, it turns out that 3 goes into both 45 and 243. Dividing by 3 up in the numerator, we get negative 81, and down below we have 15. But it turns out those are each divisible by 3 again, and we have negative 27 up in the numerator and 5 down below. So this gives us r cubed is equal to negative 27 divided by 5 times 25, which is 125. And cube rooting both sides, we find that r is equal to negative 3/5. So that is the first thing we were asked to find, the value of r. Now we need to go and find the missing value of a1. And we know that when we go from left to right, we're multiplying by negative 3/5. So if we're going from right to left, we are going to be dividing by negative 3/5. Whenever we divide by a fraction, we multiply by the reciprocal. So basically this means we're going to be multiplying by negative 5/3. So let's take our 45. We need to multiply by it twice to get to a1. So multiplied by negative 5/3 and then multiplied by negative 5/3 again. Now, let's do this. 3 cancels with 45, making 15. The other 3 cancels with that 15, making 5. So what we really have here is 5 times negative 5 times negative 5 again, and therefore a1, the second thing we're looking for, is 125 for this problem. In this next problem, they want us to find n for the geometric sequence having the first term of 1 and the nth term negative 128, and we're told that we are multiplying by negative 2 to go from term to term to term. So I would start with 1 and start multiplying by negative 2. We get negative 2, positive 4, negative 8, positive 16, negative 32, positive 64, and then negative 128. And then we can count what term number we're at. 1, 2, 3, 4, 5, 6, 7, 8. That's the 8th term, so n is equal to 8 for this problem.